Hi guys, so in this video we are going to see some awesome concepts about combination. Okay, so we will see very general things which are very useful in further questions. So basically if I talk about this question, so this question is very easy question. This is exactly similar as our previous one, but there is one change, that is in previous question we are taking a string here. In this question we are maintaining a array which will store whether this index is placed by an item or not. Okay, so exactly same question, but in previous question we are having a string and we are printing that string, and in this question we are having a array which contains information about the items whether at this index item is present or not. Okay, so exactly same question, but we will see lot more. We will see lot more instead of this. So basically in previous question, let me talk about previous question, that is combination one. So okay, so in combination one, I have explained you about what are combination, what is permutation, what is the difference between combination and permutation, in what scenario you should find combination, and in what scenario permutation is used. Okay, how the formula is very useful, NCR formula is very useful, and we have seen the practical implementation of this formula also. So I will suggest you to watch the previous video, after that come to this solution video. Okay, but in this video also we are going to see lot of funny things. Funny, I am saying that funny because they are proved by someone, but we have not seen them. Basically what I mean to say, we will prove this formula NCR, which is equals to NC1 plus NC2 plus NC3 NC4, and this will be exactly equals to 2 raised to the power n. This will be equals to, this will be here, let's say 4, 4c1 plus 4c2 plus 4c3 plus 4c4, which will be equals to 2 raised to the power 4, 4c0 also. Okay, so we will see how this equation is satisfied. How this equation is satisfied, basically how we are going to write it, 1 plus 4, or not 4, 1 plus n raised to the power Hi guys, in this video we are going to solve combinations 2 problem. Okay, so basically this problem is the extended version of our previous one, that is combination 1. So in previous video we have solved combination 1 and this part is the extended version. So if you have seen that video, then there are very less chances that you should come to this video because I have explained all the things which are required to solve this question. Okay, so if you watch that video, then you can easily solve that question and this question also, because what we are going to see, we will see that every problem of combination can be solved using two methods. Which are the two methods? First method includes two choices. This method can be called as choice method, which is I will come or I will not come. This method is discussed in our previous video. I have discussed this method. You should watch that video. Please, I am requesting you, just watch that video and then you will explain. I will explain you this method also. In this video, we are going to discuss this method and this method. Both of the methods are discussed here. Okay, and you can solve this problem by any of the method. Basically, what is the result of this video? We will solve our question using first method and second method also. We will solve this question using two methods. Okay, two methods. Okay, very good. Now I have explained this method, so I'm going to write this method. Okay, I am going to write second method, which is in which we can solve our problem using for loop. Okay, first method includes I will come, I will not come. In this method, we will create a loop. Basically, in this method, what we are doing, we are making two calls. We are making two recursion calls. Firstly, we are putting our item, and in second one, we are not putting our item. These are the two calls I have discussed in the previous video. Okay. Now, in this question, in second method, what we are going to do, we will not make two recursion calls. Basically, we will put our recursion call into a for loop, which will traverse over all the boxes. So what is the main motive of this question? Main motive is to put k items into n boxes. Okay, so basically we have to put k items into n boxes and we have to generate all the combinations in which this method, this procedure, this can occur. Okay, so basically let's take an example. If you are having four boxes and one item, so this is an easier one. This is also discussed in the previous video. So what are the total combinations? We are talking about combinations. So what are the total combinations in which we can put one item into four boxes? So there are four boxes. Very good. We have to put one item. So we can put that item here. Correct now? So this item is put it here. These boxes will remain empty because we are having no item left. Okay, that's good. Second combination in which I will say this item, I will say that I will not sit here. I will sit to the box next to my current box. So basically what I will say I will not sit here. This is I. Okay, I am talking about this I, not I. Okay, so this I is saying I will not sit here. I will sit to the next. So I sit here. These two remain empty. Very good. After that, I will say I will not sit here also. So this will also remain empty and I will sit here. After that, one last one. Okay, so these are four boxes. I will say I will not sit here, not here, not here. I will sit here. So these are the four ways. In which we can put one item into four boxes. Okay, these are the four ways. One more thing which you can derive from this method is, this is our question. We have to print all the ways. So we have printed. But what we can derive from these ways is, there are four ways in which I can pick a box from four boxes. Okay, just listen to this. What I'm saying, there are 4 ways in which I can select a box from 4 boxes. So in first case, I am selecting this box. In second case, I am selecting this box, then this box, and then this box. So there are 4 ways. So these are exactly same thing, but you can say mirror of each other. Exactly same thing. Basically, one is saying that in how many ways I can put k boxes into n boxes. There are n boxes, and I am having k items. So in how many ways I can put k items into 4 boxes. That's okay. And this part is saying in how many ways I can pick one box from 4 boxes. Exactly same thing. Okay. So because this thing is new, this is new. We are seeing this problem for the first time, but we have listened about this case in our childhood studies. Basically, what this represent, we have to pick one box from 4 boxes. So what was the formula? 4C1. Understood now? Because C represents selection. C represents selection. C is combination. So combination can also be represented as selection. I have explained all of these things in the previous video. So if you have seen that previous video, just skip some part. Okay. So 4C1 represents that I have to select one box from 4 boxes. So 4C1. That's okay. And if you know the formula, what was the formula? How we can solve this equation? Basically, NCR represents n factorial upon r factorial into n minus r factorial. So what will be the answer? 4 factorial upon 1 factorial into 3 factorial. This will result to 4. So we can see, yeah, there are four ways: 1, 2, 3, and 4. So this equation is correct. Now, let me take this example, which I have said now that there are 2 methods to solve every combination problem. This is the first method. This method is discussed in the previous video also. So I will come or I will not come. This is the statement. So in every case, I is saying that I will come here or I will not come here. So in this case, I said I will come here. In this case, I said I will not come to this point, to this box, but I will come here. What I said. Now let's say this is item. This is item, not item. So what item is saying? Item saying that I will sit here. That's okay. In second case, item is saying that I will not sit here, but I will sit here. Not sit here, but here. Okay. In the next case, item is saying I will not sit here. I will not sit here. I will sit here. And same in the further cases. So this is the first method which we have discussed. What is the let's write pseudocode. What was the code? Basically, we are making 2 calls. First call, recursion, in which basically we are adding our box. We are moving to our next box. Whether I will put or I will not put. I will move to the next box. And if I am putting my box, so I will add answers of r plus q. Okay. This is the recursion call where q represents that I have put in my item, or you can simply write I. Answers of r is the string. This is the case of our previous question. Okay. In this question, we are having a Boolean array. We will come to that point. In this case also, I will not put that. So what I will do, I will put simply dash. So we are making 2 recursion calls. Okay, that's good. Now let's discuss what's our problem statement. Basically, our problem is asking, we are having a box. Okay. So what this box represent? This box is the size of this box is exactly same as our number of boxes. So in this case, we are having 4 boxes. So what we will do? This is our boxes array. Okay. So basically, dash, comma, dash, comma, dash, comma, dash. So basically, all of the places are represented by 0. We are having this array. I am talking about first method. I have not touched a single point of second method. I am only describing first method, that how we can solve this problem using first method. Okay. So basically, this is our array, and we in the finally we have to put something here. Let's say 0 represents empty box. Initially, all the boxes are empty, so satisfied, easy. one represents that I have putted a item to this box. Okay, so let's say this is the case. Let me create a condition. This is the case. I and I, not I, 1 and 1. So what this is representing? This is representing our or we are having 2i na. So let's remove this and 0. So what this is representing? This is representing our second case. You can see this case. This case is exactly same. Dash I dash dash. So what we will do in our final answer when we are printing na, what we will do? We will traverse this box array. And we will check whether at this position 0 is present. If there is 0, so we will print dash. And if 1 is present, we will print I. So we are traversing this array. 0 is present, so I printed dash. 1 is present, so I, then 0, so dash and dash. So we got the exactly same answer. Understood? So we have solved this question. Till now, I have explained how we are going to solve this question. But I am extending this video just to explain you the another way in which we can solve this problem, because both of the methods are used inversely. They can be used in any way. Okay, so when the question is suitable for you to solve in this method, you should solve this method. But if sometimes in some cases this method looks some bit hard, that's why I am going to explain you the other method in which we will traverse our array. Okay, so let me explain that method also. You guys understood now what we are doing. Basically, we are going to make calls. I will put here, I will not put here. I will put here, I will not put here. And after all the boxes are filled, that means my current block becomes greater than total block. That means I have filled or I have traversed all of my boxes. In that case, we will do this. We will traverse our box array. We will check if 1 is present, simply print I. If 0 is present, simply print dash. That's easy. This is the first method in which we can solve this problem. Very good. Now let's move to our second problem. Okay, just keep focused. I have explained first method in which I will go or I will not go. There are two cases. Okay. In this method, basically what we are going to do, we will create a for loop. And we will make only one recursion call. So let's see what's our case. Basically, we are having 4 boxes. Initially 4 boxes are empty. Very good. Now I make a call, I am making a for loop. I am traversing all the boxes. Basically, just imagine the scenario. I am traversing all the boxes and I have provided some index value, that from that index value you have to traverse all the boxes. Okay, so initially my index value is -1. -1 represents that I have not traversed even a single block. So what I will do, I will start my loop from this let's say this is LB, least block plus 1. I will start my loop from least block plus 1. Okay, leave it. So let's see. Basically, I am making choice for this first block, then second block, then third block, then fourth block. Okay, so 4 choices are made. Very good. Let me remove this. Okay, initially we are making choice for -1 block. Initially this is -1. That means we have not made any choice. In this case we are making choice for 0th block. Or you can say in let's take another point. This is -1. Okay, so let's take it -1, not -1. Let's take it 0. 0 represents that I am making choices for 0th item. What this level is representing, let's take levels. Okay, let's take levels. So what every level is representing, level represents that I am going to make that level item choice at this level. So basically 0 represents that I am going to make all the possible combinations for 0th item. Okay, that's good. In this case, this is 1, where 1 represents that I am going to make the decision for first item, for one number of item, for one number item. Let's write it, one number of item. That's good. So in this case, all the combinations which will come for the one number of item. So let's see what are the combinations. Basically, if I am putting my item here, so what I will do, I will write here I, then rest of the three will remain empty. Understood? For second box, so first remained empty, second is I, then remain empty, dash dash I dash 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 I. So what you can see that I have created the loop. I have created the loop for int I equals to idx, and then till length. After that, I am making the call, and before making the call, I am putting that item onto that index. That's okay. So for one number of item, leave it. For one number of item, how many combinations we are making? We have discussed this problem now. We are having 4 boxes. We have to make one item's choice. So 4 C1, that is 4. And what were choices? I dash 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 I dash 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 I dash 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 I. So these were the 4 choices to put one item into 4 boxes. You can see they have come I dash 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 and exactly same. So what this is representing, at every level we will get the total number of combination for that item. Okay. So in this case, we are seeing for 4 boxes and 2 items. So you will see that this at this level, 2 number of item, at this level we will get our answer. Just remember our answer. Our answer is that you got the first method now. So by first method, just tell me your answer. Okay. Initially all the boxes are empty. Okay. We have put our item on the first box. So there are two items. So first box, I have put it as first box. Then second item is put here. First item here, second item here. Now I will make all the combinations for second item. So this will remain here. I will say I will not sit here. I will sit to the next. That's okay. Now I will say I will not sit here. I will sit here. Very good. Now this I said that I will not sit here. So this will remain empty. This will sit here. Second I will sit here. After that, this I sit here. This I will sit here. After that, I and I. And no more choices. No more choices for any of the I. So we are having 6 cases. Okay. So you will see these cases will come here. Okay. For 2 number of item, we are doing our solution. Okay. So basically, let me remove this. Now we are having second item. For second item, we are doing our choice. This is empty. So what we can make choice for this box, and this box. So there are 3 boxes. So 3 choices. Now this box is empty. So we can make choice for this box and this box. Understood? Now this box is empty. So this we can make choice for this box, and in this no further boxes are empty. So you have seen that I am not concluding these boxes. I am not taking these boxes into consideration because if I will take these boxes, then what will happen? Permutations will be created. I have explained this thing in the previous video. So I am not going to explain this in this video because the video will be very lengthier. Okay. So basically we will not take the previous boxes because it will create combination. So we will take further boxes, forward boxes. That's okay. So in this also we have checked further boxes, further. Okay, that's okay. Now if I put my item here, so what will be my case? I dash dash. Now I am putting my item here. So I dash. In this I dash dash I. Very easy. In this dash I dash. In this dash I dash I. In this dash dash I. And in this no. In this we can't do anything because these are the choices now. So we have seen. So you can see for 2 number of item we are having 6 answers. 1, 2, 3, 4, 5, 6. We are having 6 number of answers. That's good. But is this answer same? So let's see. I dash dash. I dash dash. I dash. I dash dash I. So exactly same. exactly same. We are having 6 number of cases, and all the outputs are same. All the outputs are same. So what we are getting is, we are not making choices that whether I will come, I will not come. We are creating a for loop, and that for loop is managing all the answers at each and every step. So at zeroth index, at zeroth level, that means for zero number of item, for zero number of item, how many ways are present? 4C0. Okay, na? 4C0. So yeah, we got our answer. This is the case when we are not going to put any item on the 4 boxes. We got our answer. This is correct. For one number of item, 4C1. So we got 4 answers. For two number of item, 4C2. We got our answer, 6. That's good. And for 4C3, now it's the turn for 4C3. Okay, because I'll remove this. Now 3 number of items. 3 number of items. Okay. So what we can do? We have to again make our calls. So we can make our call from this side, this side, this side, this side, and yeah, yeah. So I dash I dash I dash I and dash I. So there are 4 number of ways in which we can put 3 items in 4 boxes. What are the ways? Firstly, put all the boxes on the first 3 boxes. Okay, so basically let's check whether these are correct or not. 4C3, which is equals to 4 factorial upon 3 factorial into 1 factorial, which is equals to 4. So we are having 4 outcomes. This is also correct. So you can see we have generated all the combinations. Similarly, the last one, 4 number of items. 4 number of items. At 4 boxes, we can simply make at max 4 items. So what will happen? Basically, this is empty. This is the only case. So I, and I. So this is the only combination in which we can put 4 items into 4 boxes. So this is one. So yeah. So at every step, we are getting our answer. At every step, we are getting our answer, and we have to choose. We have to choose that what was the answer. What is the case in which we have to get this item? So basically, we are having 2 items now. So at this case, we will get all of our answers. Understood? So this is how we are going to do this. Exactly same. Okay. So I think I have explained you enough. Basically 2 choices. First method, either I will come, I will not come. In second, we are making choices using for loop. So firstly, index value is 0. So 0 to length. After that, the index value get increased. So 1 to length. In this, 2 to length. Then 3 to length. Then 4 to length. Okay. So let's code this problem. So let's switch this this code editor, and now in C++, basically I have explained all of the concepts. This question is very easy. So what we have to do? This is LB. LB represents least box. Okay. So basically this is -1. -1 represents that we have not included any box till now. So what we will do? We will start from our indexing LB plus 1. Okay. So what we will do? We will start our loop from 4 int I equals to LB plus 1, which will start from 0. Okay, so LB initially it is -1. You can see it is -1. So now we will start from LB plus 1. Basically, after that, LB or not LB, I is less than ARR dot size to traverse all the boxes easily. Okay, after that, what I have to do? If I have already put in some item on that box, that means if boxes of I equals to 1, that means some box is present, some item is present on that index. So in this case, what I have to do? I will, or I can write here 0. Why 0? Because if the box is empty, 0 represents that the box is empty. So if box is empty, so what I will do? I will put an item on that position. So I put the item. Now I will call for all combination. I will call the recursion function combination, and array will be passed exactly same. Current item. So I have put it 1 item. So current item will be increased by 1. Total item will remain same. And now least box will be I. Because currently I am on I. So I have cleared. I have put it an item on I. So I will be passed. Okay. And then after all the combinations is printed, I will make our box empty, so that further combinations should be printed. Okay. So, and if the base case is if current item, that means if CI is greater than total item, that means I have putted all the items, all the required items, and now I am my value is greater than total items in the tree. Just remember, when we are at second level, we are creating all the combination for 2. When we move to 3, we should stop. Okay. When we are moving to 3, we should stop. Okay. And after stopping, what we have to do? We have to traverse our array, or not array. We have to traverse our vector. I is less than arr dot size. Then we will see if 1 is present on that index. If arr of I equals to 1, that means some item is present. Else, then we have to simply print no. So cout I. In this case, we have to print I. In this case, we have to print empty. Very easy. And after printing all the I and dash, we have to change our line and then simply return. So this is the whole program. I hope you guys understood. So basically, we are having compilation error. What's the error? On the line 21, boxes of I. Oh, not boxes, array. Okay. So it is array. No problem. Now, let's run this again. Okay, now, so you guys understood now basically why we are stopping at Ci greater than Ti, because when we are at second level, when we move to 3, we should stop. We cannot stop at second level. Otherwise, the elements, the combination of second level will not be printed. So we will stop at 3 and we will print all the combinations at second level. Understood? So I hope you guys understood. I have enough explained you. Both the methods are explained. This is you can take this as your homework to do this question using first method. Exactly same. I will come, I will not come. Two choices. Understood? So that's okay. We will meet in the next video. Until then, bye.